Alright, thank you so much. Welcome to my YouTube channel. In this video, we are going to discuss on how to calculate the discharge or the flow rate of fluids. Alright, so we're going to solve a number of questions where we are going to learn how to calculate the discharge or the flow rate of water in this case. Alright, we'll generalize that to the flow rate of fluids. Alright, so thank you so much. I urge you to pay attention, try to solve these questions. You can pause the video, try to solve it somewhere, figure out what to do, and then you can continue with the video so that you can confirm if your answer is correct. Alright, you are the driver, so let's get started. The first question reads, the diagram below shows water being drained from the tank at a speed of 5 meters per second, right? So take note of that. Through a circular pipe of inner diameter 30 centimeters. Now calculate the rate of flow of water from the tank in liters per second. Alright, so what the question is talking about is what we can see here in this diagram. Okay, let me just use something here. Alright, so this is what we can see. We're able to see the tank of water here and water is being drained through this circular pipe, as you can see, right? Now this circular pipe, as you can see from its tip, it has the inner diameter of 30 centimeters. That's what we have been told, and we can see water is being drained through that pipe. All right, so how do we calculate the amount of water that is running from this tank per second in liters? All right, so the first thing we have to do is just to write down the formula. So we know that the formula for the flow rate is equal to cross-sectional area, right, multiplied by the velocity. Now the cross-sectional area of what? Of a pipe or of a medium through which water is draining, right? All right, so the formula, this is what we have. This can be abbreviated as flow rate or discharge of water is equal to cross-sectional area multiplied by velocity. Now remember, the value of A, we are saying the value of A is the area of the medium or the pipe through which water is being drained, right? Right, so how are we going to calculate the area? The velocity, of course, we have been taught, right? Now I also want you to take note of the units of measure that we have. We have 5 meters per second, and the inner diameter is given in centimeters. Obviously, you can see that you can't deal with calculations in different units of measure. So you would decide to change either centimeters to meters or meters to centimeters so that you can have a balance of units of measures you calculate. So let's do that. We know that 30 centimeter is equal to, if we have 30 centimeters, changing this to meters, we can have 0.3 meters, right? So for me, I've decided to change so that I can calculate this question in meters. If you want, you can do the opposite. There is no harm, right? Right, so we have, since the cross-sectional area of a pipe is circular, which means we need to calculate the area of a circle, right? Because the cross-sectional area through which water is being drained is circular. Hence we need to find or to calculate the area of a circle, that is the circle at the tip of this pipe, so that we can find how much water is being drained at a given second. All right, so we know that the radius, if we are to calculate the radius, since we have been given the diameter, the radius, we need to divide the diameter by 2 to find the radius, because the radius is simply the half of a diameter, right? So if we do that, we're going to find radius is equal to diameter divided by 2. Now remember, our diameter, we have changed it to 0.3. We divide that by 2, we have 0.15 meters, right? Now note also that the area of a circle is given by pi r squared, right? So let's go ahead and calculate the area of a circle. Hence the area of a circle, we are using pi to be 3.142 multiplied by radius squared. The value of the radius we have calculated is 0.15, right? When you square that, this is the product you are getting as the area of your cross-sectional pipe that you have, which is circular, right? Right. Now that we have the area, we can apply the formula, which goes by discharge of water is equal to area multiplied by velocity. Now the area we have calculated is 0.070695 meters squared multiplied by the velocity, which is in meters, which is 5 meters per second. Now the product of that gives you 0.353475 meters cubic. That's per second, right? Now remember, in your question, your answer should remain in liters per second. So how do we do that? Well, again, we need to remember what we know. We know that 1 meter cubic is equal to 1000 liters of water, right? Hence, what we have as 0.353475 meters cubic per second, we multiply that by 1000 liters, we are going to get 353.475 liters per second. So this is the amount of water in liters. So this is the amount of water that will be drained from this tank at a given second. Hence, the final answer will be discharge of water is equal to 353.475 liters per second. Alright, thank you so much. Just try to pause this video, pause it and try to solve. Make sure you understand what's being done here. And remember to subscribe to this YouTube channel so that you can enjoy more videos like this. Now remember, at the beginning I said we are going to solve a number of questions to do with discharge. Each question will be unique in its own way and how it will be asked. So let's go to the next question. Alright, we can proceed to the next question. Now if we go to the next question, this is the next question we have. Okay, and try to take note of the differences between the previous question and this question. In this question, it reads, the diagram below shows a cuboid tank filled up with water, right? Now, as you can see, this is a cuboid like shaped like tank. It has 4 centimeters, 10 centimeters, and 7 centimeters. Now, if a farmer wants to empty the tank in 10 hours, calculate the rate of discharge. The water should flow in liters per second. So I want to determine how many liters should flow per second if this tank is to be emptied within 10 hours. Now, remember, we don't know how much water we have in this tank. Hence, it will be hard for us to determine how the amount of water that should be drained from this tank in per second and then in 10 hours. So the first thing we need to do is to calculate the volume. Now we know that the volume is given by base area multiplied by the height, right? So we need to calculate the base area of this shape, which is 4 by 10 multiplied by the height, which is 7. Now that formula can also be written as volume is equal to length, right, which is the longest length we have, multiplied by breadth, then by the height. Now if we can abbreviate that, we are going to have length is equal to that's volume is equal to L times B times H. If you substitute, your length is 10, it's the longest line we have, the breadth is 4, and the height, how tall the tank is 7, right? Now your volume, finally, if you find the product, you're going to have 280 centimeters cubic. Now our answer should be given in liters per second. We know that 1000 centimeters cubic is equal to 1 liter of water or fluid, right? Hence, changing 280 centimeters cubic to liters, we are getting 0.28 liters, right? Now we know the amount of water in this tank in liters. We also know that 1 hour is equal to 3,600 seconds, right? So there are 3,600 seconds in 1 hour. Now what about in 10 hours? Because we want to change 10 hours to seconds. So in 10 hours, we have 36,000 seconds, right? Right. So if we apply the formula, flow rate is equal to volume in liters divided by time in seconds. We have the volume in liters, which was 0.28, divided by 36,000, right? Hence, our final answer is going to be flow rate is equal to 0.000777 liters per second. Or if you can write this answer in standard form, you are going to have 7.78 times 10 to the power negative 5. Again, try to pause this video, try to see the difference between the previous video and the previous question and this one. Take note of some changes that have been made, and try to understand the method of solving and also the understanding behind. Let's go solve another question. It is also unique in its own way, the way it has been phrased. So let's proceed. This is the other question. It reads, to plow an area of 200 square piece of land in 1 hour, Miss Isabella needs 90 liters of diesel. Now calculate the discharge or flow rate of diesel on her tractor's engine, assuming the velocity is constant as she does the plowing. So we're assuming she'll maintain the speed. Okay. All right. So let's go ahead. What do we need? This question, to solve it, first you need to have your data. What do you have and what don't you have? So look at this. We have the volume of water, which is 90 liters. Sorry, not water but diesel. So we have the volume of diesel. We have 90 liters of diesel. The time is 1 hour. We know that in 1 hour, 1 hour is equal to that's 3,600 seconds, right? Right. Now the rate of flow of diesel, if Miss Isabella will manage to plow the land with 90 liters of diesel in 1 hour, we don't know how much diesel should flow, okay, down the tank for her to manage plowing this 200 meter square of land in 1 hour. So we know what we have, we know what we don't have. You just need to apply a formula for the flow chart. That's for the flow rate. Hence flow rate is equal to volume in liters divided by time, which should be in seconds. So the volume we have in liters is 90 liters divided by 3,600 seconds. We are getting 0.075 liters per second. So this is the simplest question of all. As you can see, everything you have been given, no need to change anything. You just need to go straight and calculate that. All right. So thank you so much.